Hello guys, Mr. G here with another video. This time is going to be for the grade 10 and we are going to be solving a question on electric circuit. Electric circuit is done now in term 1, but it's a very important question because it's also going to be used in grade 11 as well as in grade 12. So before we go, please remember to subscribe for the channel so you can get all the notifications, all the worksheet. I place worksheet on a daily basis, new questions, new topics explained and so on. So subscribe for the channel and then we're going to start with question 1. It's only one question. This question says 3 resistors are connected to a battery as shown in the circuit diagram below. You have the battery there which have 24 volts. You can see it here. Now the potential difference across resistors R1 is 10, so the potential difference of V here is equal to 10 volts, and the current I1 through the ammeter A1 is 0.4 amperes, and the current here I1 is going to be equal to 0.4 amperes. This is data that they are giving us. The resistors of resistors R1, R2 and R3 are 3 ohm each. So the resistance here of R2 is equal to 3 ohm as well as R3 is equal to 3 ohm. It's very easy this question, but we're going to be getting into more difficult question later on. Define potential difference in what? And guys, once more, potential difference, the formula would be the definition. Potential difference of V is going to be equal to W divided by Q. This, guys, is the definition of potential difference. And you can read as work done, no work done per unit charge. That is the definition of potential difference. It is a very important definition because you're going to be using all the time. What is the potential difference across the resistors R2 and R3? Now, what analysis I want you to look here? The potential difference of the voltage of the potential difference of the battery, the total potential difference, not R, potential difference of the battery. Let's write here the total potential difference must be equal to the potential difference on this resistor, which is a potential difference 1, plus the potential difference of all these one together, which make, let's say, another resistor. The potential difference, and I'm going to call that one the parallel part of the circuit. Remember, the current divide the, however, the potential difference for each of them is the same because they are in parallel. You have to remember that the potential difference in parallel will be equal and the same for each resistor. So in this case, the V parallel will be equal to V2, let's say, and will be equal to V3. But before that one, we have to go to that side there. So if we substitute the total potential difference of the battery is 24, you can see it here, equal to the potential difference that passed through resistor R1 or V1, we can call that one. V1 is equal to 10 is given to us, and then the potential difference in the parallel part is going to be equal to 14. So this is the parallel part, is equal to 14 volts. And then if we apply this one to this side here, this means then that the potential difference is equal to 14 for each of them. It means 14 potential difference here, 2 is equal to 14 volts, and the potential difference here in 3 is equal to 14 volts. I hope this is clear. It's not that bad. It's not that bad. And that one would be question 1.2. This one here is question 1.2. So now in question 1.3 said, what is the reading of the ammeters A2 and A3? And this one is a very simple question. Know the following here. At this point here, the current divided in 2 parts. And because the resistance of the 2 resistors is the same, the current is going to divide equally here. Therefore, 0.2 amperes will go on this side and 0.2 ampere will go on that side. So that is how to calculate or how to get the current in this specific question. For A2 is 0.2 amperes and for A3 is 0.2 amperes. This is not always like that. It depends. Here is like that because the resistance of both resistors is exactly the same as you can see there. Therefore, the current will be divided equally. Calculate the energy consumed through R1 in 5 minutes. Now, for this question, they ask you to calculate the energy. Now, the energy here, guys, is not other thing than the work in this formula. So let's work at this point down here, 1.4. We know that the potential difference is equal to work done divided by charge. This here is what they want to calculate. That work is what they refer as energy. So this one here can be potential difference or energy. So we are looking for that one. Now, here in this resistor 1, we have the potential difference, but we do not have the charge. So we have to look for the charge. Now, where are we going to look for the charge? We are going to go to the definition of electric current. We say that electric current is equal to charge divided by time. This one is the rate of flow of charge. We have the time because they say is 5 minutes. Remember, you cannot work in minutes, and the current is given to us. We already know the current there, which is 0.4. So using this one, we can calculate the charge. Current is 0.4 and the time is equal to 5 minutes, but we cannot work in minutes, so it will be 5 times 60 because 1 minute has 60 seconds, saying that the charge is going to be equal to, and when we substitute there, the answer is 120 coulombs. All we have to do is to take this charge and substitute it there so we can calculate the energy. So now when we come back here, the potential difference is 10. So 10 is equal to energy, which is W, divided by charge, which is 120 coulombs. And therefore, the answer for the energy is going to be 1,200 joules, and that is the end of this question here. Now, the last one is question 1.5. Question 1.5 say calculate the effective resistance of the parallel resistors in the circuit only on the parallel resistors. They only want for the parallel. So 1.5, we are going to calculate the resistor in parallel. This is the question mark. So what is the formula we are going to use? 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2. Each of them is going to be a 3. So when you substitute, you have 1 divided by 3 plus 1 divided by 3. And the answer of this one is 2/3. Now I want you to note something. This is 1 divided by Rp is equal to 2/3. So now this one is a third here, 2/3. What you need to know that Rp will be equal to 2/3 to the power -1 or the inverse. So when you solve that one, you will get that the equivalent resistance is 1,5 ohm. That is the resistance for the parallel circuit. Guys, this is the end of this question. It is really easy. It is very important though, because you are going to have it in grade 11 as well as in grade 12. Thank you for watching. I hope it helped. Subscribe for the channel so you can get the notifications and the worksheets and all the posts I place in, or I put in YouTube. And I'll see you next time. Mr. G here.